Hello FTC Alberta, and anybody joining us from anywhere else. Welcome to our Climbing High strategic analysis. Now, what we're going to go through today is actually going to be something that's hopefully something you've seen, but isn't necessarily something you've seen. And because of that, I think it's worth talking about. Now, we do a lot of this in FRC, but I see it less frequently in FTC, and I think it's something that we should definitely do as a piece of everything we do in robotics competition. Karthik does a really good session on this at the World Championships about how to actually determine what your strategic analysis should be and also what your priority list should be. And today we're going to kind of focus on that priority list piece. I'm actually going to link his session down in the comments below because it's definitely worth listening to. Now, you've gone and you've read through the game rules. That's for climbing high. It's the ones we released just recently. I'm going to repeat that. You've read through the game rules. This one's nice. It's a CAD challenge. There's no game animation, so you can't lean on that as a crutch. And I do recommend that at the start of the actual season that you do read the game rules. And I'm going to say that again. You should read the game rules because when you do that, you actually pick out a lot of the details that other teams might miss. You actually see what the values of things are, what stuff is going to be worth. And that's really important. It's actually the difference between teams that do exceptionally well and those that just do pretty well. So let's break this game down. Now, I know a bunch of you have read the game rules because you've sent some edits and some questions about it. I hope we get to clarify those in the coming weeks. But at its core, every FTC game can be broken down into 3 areas of opportunity. 30 seconds of auto, 2 minutes of driver op, with 30 seconds of that being endgame. Most games kind of fall into this category, so we're going to break this one down in the same way. Now what I've done is I've actually color-coded this. So if you look at what we have here, I've actually chosen to put high difficulty in red, medium difficulty in yellow, and low difficulty in green. Now obviously something that is low difficulty is something that somebody who's, say, a rookie team is probably going to attempt to do in an actual FTC season. You see, you only get a certain amount of resources in terms of time and components, and that will influence what you choose to do as your priority here. Now, as this is a CAD challenge, it's nice because you could put custom parts onto the thing, you can build kind of whatever your heart desires, but this is a really good thing to do at the start of your season to make sure that you have a list of priorities that you are going to focus on. So as the season wears on, as stuff breaks, doesn't do what it's supposed to, you can always go back and say, all right, well, we were going to focus on this. We had this analyzed as the priority that we really should look at. So let's break down auto. I've put the term sampling in there. That's something that came from Rover Ruckus a couple of years ago, and it's basically what the initial piece where we're trying to identify our alliance's game ball are actually going to be based off of. Likewise, plowing is the idea of just bowling through all 3 of the balls. It's worth by far the least number of points on anything here, but it is quite easy to do, especially if you're a rookie team. Passing the ball between 2 robots is 10 points. I've put that as medium, but that could very easily be hard difficulty. It's relatively easy to make the pass. It's a little bit less easy to catch the pass. And that might actually be something that a robot could be designed to easily do. How we've defined passing or catching, and the case might be in the rules, is somewhat loose. There's actually a couple of really creative ways that you could deal with that particular design challenge fairly easily to make yourself either a really good passer or a really good catcher. Shooting 3s during autonomous is one of the hardest challenges in this whole thing, and it's something I'm going to put as the high difficulty. As well, shooting 1s, it's slightly easier. You're a little more lined up to it, but it's still quite a hard target depending on how your robot's designed. Lastly, parking for 5 points requires you to really become one with your encoders and know where you are in the field. But if you have that telemetry data, that's something that's of a medium difficulty. It's not exceptionally hard to do. Now, when I go through autonomous, I'm going to look at it personally and say that if I can sample, pass, and then park, which are, somewhat more difficult things to do, but still doable within 30 seconds, that's something that can get me 35 points before even starting. Now, when we put this into the game, that means that it's the same as if I were to be shooting a whole bunch of 3s in driver op. I could be ahead of the game already before we even start, and that's important. So in my version, I'm looking at a perfect sample as the kind of gold standard. That's really what I want to focus on first. So I want to design a robot that's going to be able to identify those things. And I'm going to make sure that I have that robot that can actually use a camera of some sort to identify the different colored ball out of the 3. How I pick that off the platform is actually not that important. It's way more important to be able to identify it and have the sensors in place. Okay, an intake to intake the pass and something to park would also be really nice, but as you're going to see on my priority sheet on the next page, they aren't exactly huge on the priority list here. In driver up, we have somewhere between 90 and 120 seconds for cycling. 90 at the low end assumes that you're going to need to get to the end game fast. Let's say you have a slow climb, and this is part of the analysis that you really have to look at. If I have a really slow climb that takes 25 or 30 seconds to do, how many cycles of shooting the ball have I missed out on? What's the opportunity cost behind that? Did I miss out on maybe not being able to shoot, and in exchange I might have gotten 15 points for parking on silver? Right? Those same 15 points are the same as me getting basically 2.5 really good cycles in driver up. Now when I say a cycle, I mean scoring with 2 of the balls, and I would assume in a 3-point goal. Okay, so 2.5 3-point cycles is the same as parking on silver. So if it's going to take me 30 seconds to climb, but I can cycle 3 times in those 30 seconds, 1 cycle per 10 seconds, why would I even bother parking? I may as well just go in and fire a few more balls through the 3-point goal and carry on and get more points for it that way. And that's that kind of strategic thinking you have to have at this point, right? How fast can you cycle, and what are you willing to sacrifice in order to do it? You know, in some cases it is worth ignoring a piece of the game to actually just score more that much faster. So my conclusion on this is that speed of cycles to score threes will determine competitiveness. My goal is going to be to try to make a shooter that is as accurate as possible to do those. And in my case, I'm probably going to make a shooter that's also going to try to get the balls as close to the target as humanly possible without me having to launch them in an erratic way. In the endgame, we have a really simple thing, and you'll notice how I've analyzed this. I want to break this one down. I've put the parking bronze, low difficulty, no problems there. Just park. Any drivetrain should be able to do that the way this game is designed. Parking silver is harder, but it's still only a 6-inch jump. That's not exceptionally hard to do with an FTC robot. And we've had, we'll post a few versions of this on Discord over the course of the week, but we had versions of this where robots just had linear slides, pop them up so they could fall over onto the platform. We had some versions of this where robots had roll cages, and they actually just rotated a bar on the front of their robot and rolled themselves on top of the side. And in some cases, we just had robots that just extended a little arm out in the front, tipped themselves up, drove the front end of their robot on, dropped it down, and then drove up. 6 inches, you can do that. Parking on the gold level, though, is a 12-inch jump. It is much harder. And there's a bit of a way around that if you want to do 2 6-inch jumps, one onto the silver, then one onto the gold. That's a bit easier, but again, that takes more time, which we could be using to cycle more threes. So that parking on gold, if we do it straight up, is actually something quite hard. Our buddy climb gold, now this is a term, buddy climb, is the idea, could we design a robot that could actually bring another robot with us? Could we guarantee, that our robot that is going to get up onto that platform is going to bring somebody else with us? That's a 50-point shift. I say plus 10 points here because I'm assuming that most robots would be able to probably park silver. But if your teammate can only park bronze, that's actually a 20-point jump. And that might be something that some teams look at and go, that's something I want to prioritize. Now, where did I go on this? I obviously had a key hand in designing the game, so I've had a lot of time to think about this, and I recommend that your teams do the same thing. Read the manual, think of what you see as difficult and worthwhile in the game to focus on and prioritize, and go from there. And with that being said, here is the priority list that I came up with for this game, for the CAD robot that I would design for this. And don't worry, I will be designing a CAD robot alongside of you all to try to make sure that this all works. My first priority, the thing I am pouring the most resources into right off the bat, and in a real FTC season, when we're not all caught at home from COVID, this is where we would be spending the most of our time actually prototyping and seeing if this would work, is consistently getting a shot to the 3-point goal, and I'm going to add in here with 2 game balls at a time. So load and shoot 2 game balls. And how I have to do that is get the ball as close to the target as I can, and then launch it in somehow. How we look at that, that's a big piece of this process. But I know that I'm going to look at this first, and my whole design is really going to be driven by this idea. Next priority, and this is a priority with a condition on it, and you can put conditions on your priority list. If I think I can get a gold climb in less than 10 seconds, I want this to be my second priority. And in my prototyping, this may not be the case. I may find out that the only good way to get an FTC robot on that platform is going to take 20 seconds plus. If I can't do that, I might consider just going to the priority 3 as the next thing I'm going to work on. I might even change some of these priorities. And in this case, I'm going to actually look at 2019 FRC Deep Space, and a game that had, again, this game was modeled off of the idea of deep space and the idea of the podiums of the platforms. So I'm going to look at how other robots did that in FRC that year. And lastly, I'm going to look for a consistent sample and pass. Now I list this on my priority list because when I'm building my drivetrain, when I'm building my mechanisms, I have to make sure that I have an exposed camera or some sort of sensor to actually figure out what those game balls are. I'm thinking by how far away they are this game, I probably want to put those as a camera so I can actually see them and I can then drive up to them. So when I'm designing, I just got to make sure that I have space to put. Maybe I use an expansion hub and a camera setup, or maybe I have to attach an external webcam if I'm using a control hub to actually make it so that I can sample that game ball out of the 3 and get those easy 20 points, or relatively easy 20 points as they are. Now with this for the inspiration, I think I can go about doing some initial sketches as to what I think I might want this robot to actually be. I also noticed that on here I've actually written down I want a holonomic drivetrain of some sort. For those that aren't familiar with the term, holonomic means that the robot can drive sideways just as well as it can drive forward or backward. And we'll talk a little bit about drivetrains in the next couple weeks again, but Mecanum would be an example of this. An example of this would be an X drive, an example of this would be an H drive, an example of this could be a swerve drive, though we rarely see those in FTC. Those are going to be my priorities, and these things are what are going to kind of guide my thinking over the prototyping phase and over the idea generation phase, because now I know where I think this robot wants to go, and I've got some ideas to go for it. I hope that helps. I hope to see some of your strategic analysis of how you think this game is going to be played or could be played in the very near future, hopefully by the end of this week, so we get some teams together and they can actually start going through the CAD challenges, building some robots, designing some robots, and seeing how this game might play out. Cheers, and good luck.